This is Yijia from Origo. Thanks for listening to this serious talk about Origo's Whitepaper walkthrough. And today is the sixth day, and today's lecture is more focusing on the infrastructure or chain part, but actually more focusing on the consensus protocol. So I still want to go through to yesterday's content. Yesterday's more talk about our detailed protocol, uh, the detail of the execution step and the settle step, and how we use zero knowledge proof to protect the commitment, to making the commitment matching the data, encrypted data, and the executor execute the result could be verifiable on chain to ensure higher security. And how does the blockchain actually doing the uh, private transaction, and what kind of function will be supported? Yeah, it's mentioned yesterday. So if you're interested in that, just go back and listen to that. And today, I'm gonna mention the talk about the consensus protocol. So for blockchain, there are all kinds of consensus protocol, and it's improving, keep improving. So our focus, Origo's focus, is not focusing on improving a lot on consensus protocol, and we just want to make the consensus protocol simple to understand and work as we need, and can support our scalability. So for usual a consensus, there are two kinds. So one is a classical consensus. Maybe people hear about that. It's like a PBFT or Paxos. They actually using a lot in distributed systems, like a normal normal in industries for distributed system. It's has really high transactions throughputs, but actually it cannot support a large network. It has to be a small network because sometimes you need has some leader or a, a main node, and it's permission based. So if there's some lots of bad nodes within this kind of network, it won't scale. It won't work as it it plans to. Yeah. So and the other type of the consensus will be a blockchain consensus, people. Yeah, I think definitely you hear about it. It's like POW, POS, and the new POA. This actually is pretty good for a large scale permissioned a blockchain. Like everybody can join to the network. It doesn't need to be permissioned, and it could be really large. And but the problem for the blockchain consensus, POW, POS, POA, is somehow it's limited by the worst nodes in the network. It's somehow blocked it. There are definitely a new design for this kind of blockchain consensus, which solving a lot for the problem. I don't want to mention in detail today about that. And for those like a POW, POS, POA, like blockchain normally use consensus, the transaction throughput is it's lower than the classic consensus. But you know that the classic consensus need to be permission, right? So um, as an overview, is the classical consensus is fast, but it's permission. It only handle small network size. It cannot if it goes to really big network, then the network overlay, the latency will cost a lot for the classical consensus. So network could not be really large. It's better to suit for hundreds, several hundred nodes will be good. But if it takes to thousands or 10,000, then but it will be pretty slow for even classical consensus. And for blockchain consensus, it handles really large network and with permissionless. Everybody can join, even as a bad node. And it's slower compared to a permissioned. You can think about permissions as a fast node, right? So could it be any better way to actually matching this together to build up something like work and with like a little faster, was faster. So yeah, there are lots of like projects talking about or like talking about hybrid solution. So hybrid solution is like want to make the consensus protocol similar performance like the classicals, and also without require the permission setting for the classical. So it's more like okay to matching the speed as the industry, as fast as the industry. So this is our like thoughts, our like basic idea to design this consensus. So our design is to make the consensus to be two layer. You can think about it like yeah, just think about two layer. So one chain is normally as the transaction chain. So it's similar to like now like a Ethereum, Bitcoin, whatever. It's like validate those transactions, right? That's the information chain. Yeah. And there's another chain, which is identity chain. I will explain later. So the identity chain is different from the transaction chain. It's actually it doesn't need to validate the transaction is correct or not. But it's still like a blockchain. It's a still blockchain, but maintaining all of the identity for the for the validator's information. I will talk about the details later. I guess maybe you get confused right now. So the identity chain use like a currently wide adopt like a blockchain focused consensus. It could be like a POW or POS or whatever. Its main focus is trying to resist to the Sybil attack. So okay, let's go back. I guess you got confused. Why there's identity chain? Why we need that chain to actually make this hybrid? How to make the transaction running on PBFT but still works? You think about like a PBFT. It cannot goes to really large network, and so it could be like a hundreds, like several hundreds nodes. You can think about okay, we can random select hundreds from all the nodes, and then making them running PBFT. But the problem is like maybe when you select those like hundreds, lots of them are offline, or lots of them are not like a good machine, or lots of them are not that strong, and then you choosing them as permission, and to build up a temporary like a PBFT network, then your speed will be bounded by those like snow machines or like not network not well at that time machines, which will slow your PBFT, right? So you want to select a group of people, a group of nodes are really active at the time when you want to run the PBFT. So then there's identity chain. So you can use like either POW or like a POS or normal ways to select. So it's more like get the identity or like to verify or to prove yourself. Okay, I'm a strong node. I have like good network. If you're using POW, it's more like proof you are a strong node, right? As computation, and as POS, it's more like okay, I'm an important node, and so it's more like want to like select the group of active nodes. So it's not say if you're running like a normal, select a random nodes from all of the nodes, then could be lots of nodes and not like a good network, which will slow down the PBFT a lot. So using like so first you run a selection, you run a POW or whatever, run a POS, you select a group like people running, and then you're mining your identity to prove okay you are active node and then strong node, and then from that active group random select some like hundreds of nodes to run the PBFT will be faster because those nodes are active at the first stage, at the first step when running the identity mining, and then go to the second step like running the transaction validation. They will be active fast, right? So it's more like that's the hybrid. So using the normal ways to mine the identity chain, and then select a group of people, group of nodes running the PBFT. It could be faster, right? Then, yeah, let's go back. And then, so for the identity chain, we just want to use some like widely adopted blockchain focused consensus. And it's a chain of like an identity block. So each block contains a list of nodes, which are like eligible for the transaction chain validators. So it's more like you're doing mining, you're doing POW. Let's say if it's POW, then you are say it's like you're mining POW for like the permission to run the PBFT for the transaction chain. So yeah, so the transaction chain are using like a permission based. So it's like it's more like saying like when the identity chain is mining the permission for the permission based PBFT. Yeah. So the transaction chain are using like a PBFT, and it's a small network. It's like hundreds of nodes. But it's not that small, right? Otherwise, it will be not that safe. So, and to keep it fair, so we cannot say, okay, you run and then select a group of people and then keep it forever. Then it's not secure, because some of the nodes may drop offline, and then you cannot let them run forever. And the people may see it's unfair, right? Because I keep running identity chain and mining identity chain, and then those people select for running the transaction will keep forever. No, that's unfair. So it sets like a periodical validation election. So it's more like after a period of time, the identity chain will mining another block, right? And then it will select another group of people to validate the transaction. So it's more like it's fair. So it's more like maybe like in this 10 minutes, is this like several hundred nodes for running for validate the transaction, and then after a while, after 10 minutes, it's another like group of nodes running the validate the transaction. So it's fair. So everybody has the chance to actually to be the permission to run the consensus around the transaction validation. Yeah. So we also need to support a random beacon. It based on the BLS like a signature. This is a more technical detail. So the reason for that is like we just mentioned that we want to say we need to periodically select the validator, right? So how to make sure it's fair? You need somewhat like a random function, right? So yeah, so this random beacon will be used for electing the validators, and also it could be like if we do sharding later, then we can use this random beacon for also doing the sharding work. So yeah, so that's basically today's like topic. Yeah, I just want everybody to understand so what is like a hybrid consensus, how this consensus like improve the normal behavior, and then to improve the scalability. So we just want to keep this simple, keep the consensus simple at first, and also can enable the speed up. Yeah. So tomorrow I may go through some like other chain infrastructure, maybe like sharding or like EVM work, or I will talk about the trust model, because there are other ways to doing like privacies or like running stuff off chain, and those of the work have different trust model. So in the later like lectures, I will mention those stuff. So I haven't think about the sequence of the content, but yeah, that stuff will be mentioned later. Yeah. Thanks for listening, and hopefully you enjoy the talk. Thanks.